Now, first of all, when you spend money, your total spending will be the price times the quantity. And if the price is low, you will buy more. If the price is high, you buy less. Your total spending would then be the rectangular area. So at the low price, your total spending would be the long, short rectangle, and at the higher price, your spending would be the taller rectangle. Okay. Now, as a business owner, when you are setting your price and when you're deciding whether you should raise your price or lower your price, you're going to want to know what will happen to the quantity. You know it's going to change, but by how much? Because if you raise your price, people will buy less. But whether you make more money or less money will depend on how much less they buy. Right? If you raise your price and people buy a lot less, then you're probably going to lose money. But if you raise your price and people only buy a little bit less, then you're probably going to make more money. Right? Or going the other way, if you lower your price, then people will buy more. But the price is lower. So if you lower the price and people buy a lot more so that it makes up for the fact that there's a lower price, then you'll make more money. But if you lower your price and people only buy a little bit more, then you're probably going to lose money. All right, so what the chapter is about then is called elasticity, which refers to the quantity change in response to the price change. So when the price changes by a certain amount, how much will the quantity change? Will the quantity change a lot, or will the quantity only change a little bit? So it's important for you as a business owner, but it also helps to explain things like consumer behavior. So say a carbon tax, for example, it raises the price of gas. If you're driving a car and then the price of gas goes up tomorrow, can you do much about it? No. So gas in that situation would be a necessity to you. You're not going to have any options by tomorrow. So you're just going to have to fill up and pay the higher price. But say a couple of years from now, if the gas prices continue to be high, then you could plan for it. You could say, okay, I want to save up and buy, more fuel-efficient car, an electric car, or something like that. Right? So our response to the price change really depends on the circumstances and what kind of a good it is. All right. Okay, so elasticity. So do consumers spend more or less? Do consumers spend more or less? It depends on how much the quantity changes when the price changes. Okay, and so this is what I was just talking about for the business owner. For a business owner, your revenue is the spending by consumers, which is P times Q. So you're going to want to know when you change the price, how much will the quantity change? Okay, so when the quantity does change a lot, that's called elastic, and we could be talking about demand or supply. So when the quantity changes a lot in response to the price change, that is called elastic demand or supply. Okay, the kind of goods where people will have elastic supply are things that we don't need. So jewelry stores always have sales because for most people, you wouldn't even walk into a jewelry store and pay regular prices. You're not even going to go there. But as soon as you see a sign that says there's a sale on, then you'll start thinking, oh, maybe I need something. Right? So it's not a necessity. It's a luxury good. Okay, so a luxury good. Or when you have a lot of choices. So when you have a lot of choices, you're going to be more sensitive to the price. So if there's a lot of substitute goods, right, where you can pick one or the other, then you're going to be very sensitive to the price because that's what you're going to focus on. And you're going to buy more of whatever one is cheaper. And so then if there's even a small difference in the price, you're going to suddenly buy more of the one that's cheaper and less or even none of the other one that is more expensive. All right. So luxuries and goods with close substitutes. And so one example of goods with close substitutes is gas again. And so I put, for example, Esso gas. So when you need gas for your car, do you need Esso gas? No, you just need gas. And you've got like 10 different types of gas stations to choose from. And so especially when they're located close to each other, you're going to be very, very sensitive to the price. And you're going to go to whatever one is cheaper, even if it's only cheaper by like a penny a liter. So Esso gas, for that particular gas, we would say your demand is very elastic. If it's the cheapest one, you'll go and fill up there. But if it's not the cheapest one, then you just won't even go there. All right, now the opposite is when the price changes and the quantity does not change very much. So this will be inelastic. So this will be inelastic demand or supply. And then the examples will be the opposite. So necessities. Necessities will have an inelastic demand, such as gas in general. Right? So now you don't need Esso gas. You can get another type of gas, but you do need gas if you have a car. So gas in general, you would have an inelastic demand for it. Okay, so so necessities, so I put gas, basic foods like milk, toilet paper, so for necessities, if the price goes up, you might try to buy a little bit less, but you can't really get by with much less. So you're still going to buy pretty much the same quantity. But at the same time, if the price goes down, can you buy a lot more? No, right? You can only drink so much milk, right? Or toilet paper. You don't need extra toilet paper. You can stock up maybe on that one because you can store it. Yeah, but the other ones, you can't stock up on milk too much because it'll go bad. And gas, I hope you don't stock up on gas. That would be kind of dangerous. Okay, and then goods without close substitutes. So the opposite of elastic demand, goods without close substitutes. So an example would be avocados. Is there anything similar to an avocado? No, there's nothing similar, right? So if you're like going to have Mexican tonight, you're going to have to buy an avocado. And they're expensive, and that's one of the reasons why they're so expensive. There's just no substitute for an avocado. All right. Okay, so now into how we measure elasticity. So what we're trying to measure is how much does the quantity change when the price changes. So we're going to be making a relative measurement, and we'll be calculating percent changes in the quantity and percent changes in the price, and then calculating the relative change between the two. So the percent change in QD, quantity demanded, we're doing demand first. We'll do supply next week. So demand first. So percent change in quantity demanded relative to the percent change in the price. Okay, and then the formula. All right. So, what do those lines mean? Absolute value, that's right. Because we can leave off the negative sign, we're always going to get a negative result, because if P goes up, Q will go down, or if P goes down, Q will go up. So you always get a negative result, and so you can just leave it off. That's what it means. All right, so now calculating percent changes. So we're going to go through this example here, steak dinners at the Keg. So the price falls, and then the quantity demanded increases, and we need to calculate percent changes. Now, when you calculate a percent change, there's a couple ways to do it. So if you go from the first number to the new number, you can calculate the percent change relative to the first number, but then you'll get a different result depending on if you go this way or if you go that way. And so instead, for elasticity, we use the midpoint method, which means when you're calculating the change between the two numbers, you calculate the change relative to the middle, or the average of the two numbers. All right, so the formula then would be the difference between the two numbers divided by the middle of the two numbers, and then times 100%. Okay. All right, so we'll do the quantity change first. So it goes from 50 to 200. All right, so this would be 200 minus 50 over 50 plus 200 divided by 2 times 100%. Okay, and then the price change. So price $40 to $30. So this will be 30 minus 40 over 30 plus 40 divided by 2. So this will be a negative result, but then we're going to take the absolute value. So it won't matter. Okay. Okay, so now we put them together. Going back up here, so this is what we want to do. We want to put our percent change in Q divided by our percent change in P, and then just leaving off the negative sign. All right, so 4.2. Now, when you do the calculation, the result will simply be a number. So no units, because all the units have canceled out, right? The units of steak dinners canceled out, the dollar signs cancel out, the percent signs cancel out. So you just have a number. And then the size of the number will tell you how elastic or inelastic the consumers are. So a bigger number like this, where you're getting a bigger number because the percent change in the quantity is quite big compared to the percent change in the price. That will be for a luxury good, right? Which obviously steak dinners would be a luxury good. Okay. Now, elasticity, oh, that didn't work. Uh-oh. Uh-oh, my buttons aren't working. Oh no. That's weird. Oh, there we go. Okay. So elasticity is a topic where the calculations can get kind of boring, of course. That's okay. But it's interesting because it's a topic where you get to understand why you respond differently to price changes depending on the good. And then also it helps to explain pricing strategies by businesses, right? So say something like milk. Do you ever see milk on sale? No, because there wouldn't be much point, right? Like I said, even if milk goes on sale, there's only so much milk you can drink, right? And you can't store it for later, not for very long anyway. So they don't put it on sale because they're not really going to make much more money. Whereas luxury things like, say, travel cruises or whatever, touristy things, those things are the kind of things that go on sale because those are the kind of things where people really respond to a small price decrease. But it also helps to explain the different prices that are charged. So, for example, a lot of businesses will offer student discounts, right, or some kind of student price. Now, why is that? What is a student's demand compared to like an adult with a job? Your demand is lower, you don't have as much money, but it's also more elastic. Because you don't have as much money, then more things to you are luxuries, right? Whereas when you become a working adult, you've got a higher income, then things aren't really luxuries anymore. Now things will start to become necessities to you, and you're just willing to pay higher prices. Or for kids as well, kids' prices are always lower. Yeah, I bought pajama pants at Walmart. I've discovered that I can fit into the extra large girls size, which is great because they're only $7. Now, why are girls' pajama pants so much cheaper than adult ladies' pajama pants? Because the parents have much more elastic demand for kids' clothing, right? When you're a parent, you're like, no, my kids don't need new pants. Whereas pants for you, you're like, it's more of a necessity, I guess. Anyway, so they are, yeah, tip, there you go. Look in the kids' sizes, extra large. Okay, now, going back to the boring calculations. So this is what we put together here. we did all this, but you notice if you put it together that we can cancel some things out. We can cancel out the divide by 2, and we can cancel out the times 100. And then our calculation will be a little bit better. Okay. My pajama pants are pink with unicorns on them though, so that's the only downside of buying it in the girls section. But I don't care. There we go. Okay, so the formula is still not that great, but it's a little bit better. All right, so exercise 1. Okay, when the price of eggs increases from $3.50 per dozen to $4, Joe decreases his demand from 16 dozen per year to 15 dozen per year. All right, okay, so we just have to plug everything in. All right, so Q change goes on the top. Q change 16 to 15. Okay, so 15 is the Q2, so 15 minus 16. 15 plus 16. Price change on the bottom, so price goes from 350 to 4, so 4 is the P2. All right, now this will be a calculation where you're going to have some small numbers and you're going to want to keep several numbers after the decimal just until the very end anyway. Okay, so I'll do the top first. So 15 minus 16. Okay, so minus 1 divided by 31. I'll keep 4 numbers there. Okay, and then on the bottom, 4 minus 3.5, so 0.5 divided by 7.5. Okay. Okay, but then for your final answer, you can just leave 2 numbers out. It's plenty. So I get 0.48. Okay, now this is a smaller number. This is less than 1, and we're going to be getting less than 1 because the percent change in the quantity would be less than the percent change in the price. It's a necessity, right? Eggs. Yeah.
Why did we take the 2 and the 100% away at the top?
Oh, just to make it a little bit more simple. Yeah, you don't have to. You don't have to. Just a little bit less to write down.
So it doesn't make a difference?
Okay. Now the second question's a little bit different because you're given the percent change. So suppose the price of diamond earrings decreases by 40% and Elaine's price elasticity of demand for diamond earrings is 3.8. By how much percent will Elaine's quantity demanded change? All right. Now, because we're given the elasticity and the percent change, then we can't use this formula, because for this formula, you need the different quantities and the different prices. So for this one, we would just go back to the previous page. Oh, no, I don't have it. Anyway, on the last page. Okay, so this is the elasticity formula. Okay. So these 2 formulas would get you the same result, but this formula you would only use if you have the 2 different quantities and the 2 different prices. But this one we can use for this question here. Okay, so the price of diamond earrings decreases by 40%. So this number here is 40%. The elasticity, the question says, is 3.8. And so we can use this to calculate the percent change in the quantity. Okay. Okay, so price elasticity of demand is 3.8. And then we want absolute value. We want to find X over 40%. Okay, any questions? Yeah.
So for the first one, you're not going to have a unit, but for the second one, you will?
That's right. So the 3.8 does not have any units. Yeah, but here we would leave the percent sign because we're just calculating the change. That's right. Yeah, but the elasticity results, like the 0.48 and 3.8, have no units. Yeah. Good. Any other questions? Okay. All right. Now, on this page, we have a demand curve with different points. And what we're going to do is calculate the elasticity at different points on the demand curve and see how it's different. Because the elasticity is different from the slope. Right? So if you were calculating the slope of the demand curve, you would be calculating just a change relative to a change. But we're calculating a percent change relative to a percent change. So it is different than the slope. And because of that, we're going to get a different result depending on where we are on the demand curve. So up here, for example, the price changes by $1. Here, the price changes by $1. Here, the price changes by $1. But when you calculate the percent change, it'll be different because $1 change is a big change when the price is only $2 or $3, whereas $1 change is, as a percent change would be smaller when you have a higher price to begin with. And then same with the quantity changes. All right, so A to B first. Now, it doesn't actually matter what direction you go when you're doing the calculations. That was the purpose of using the midpoint method. It doesn't matter if you go from A to B or B to A, you're going to get exactly the same result. So, okay, so A to B, quantity change goes on the top. All right, so the quantity would go from 2 to 3. So 3 is your Q2. So 3 minus 2 over 3 plus 2. All over. Price change goes from 9 to 8. Okay, so we get 3.4 for that one. Now we'll go from C to D. Okay, so quantity change first. I'm saying that because that's a very common mistake for students to get it mixed up. They put the price change on the top, quantity change on the bottom. Quantity change on the top. Okay, so quantity change is from 5 to 6. And price change is from 6 to 5. Okay, so the top and the bottom will be the same, and so that will just be 1. Okay, last one, E to F. So quantity change is from 8 to 9. Price change 3 to 2. All right. So you can see how we get very different numbers. So it's definitely a different calculation than the slope. Even though at all 3 changes, the price change was $1 and the quantity change was 1. So that was the same all along here. But the result is quite a bit different depending on the percent change. All right, now from A to B, we're getting a big number that's more than 1 because the top is bigger than the bottom. And that's because the quantity change as a percent change is more significant than the percent change in the price. Here, the percent changes are the same, so we get 1. And then here we get the opposite of the first one. The percent change in the price is now more significant or bigger than the percent change in the quantity. So we get a number that's less than 1. So this is how we will classify whether good has elastic or inelastic demand. If it's greater than 1, 1, or less than 1. Okay, so demand for a good is elastic if the elasticity is greater than 1, inelastic if it's less than 1, and if it's exactly equal to 1, then it is called unit elastic. Okay, so last thing for today then. So this corresponds to the different areas of the demand curve. So in the upper region, that is where demand will be elastic, just like in the points A to B on the last page. Right in the middle, that's where it will be unit elastic. And then in the lower portion, it will be inelastic.